This is problem number 8 on section 1 of chapter 7. So for the first part, they want the best point estimate of the population proportion. Okay, we have this information here, that's the sample size. We have that 557 say yes to a poll out of these 1060, and they want a 95 confidence level. Okay, so first part, we need to find this value, which is just the proportion of people who say yes in the sample. Okay, so that value is obtained by dividing 557 by 1060. Okay, so that is 0.525. Okay, you round it up to a third decimal place, and that is what we know as the p hat, the one from the sample. Okay, the margin of error. This formula is the one that is on my math lab, and the one that the author provides. That is the margin of error. Okay, and that is equals to z of alpha by 2 times the square root of p hat times q hat over n. Okay, first of all, we need to find that critical value, and then to find that critical value, let me show you this. We need to find, first of all, alpha. Alpha is obtained by doing 1 minus the confidence level, which is 1 minus confidence level is 95%, so it will be 0.95, so that is 0.05. Okay, that means about 95% is going to be here in the middle, right? 95%. So so 5% will be split in these two regions. Okay, so you have 95% in the middle. I need to have a 2.5% here and 2.5% here. Okay, so alpha by 2 is half of this, right? Alpha by 2 is 0.025. Just divide this number by 2. So let me find that critical value, which is the value whose area to the right is 0.025. Okay, I need that value first of all, because I need to use it for this formula. Okay, so I type a inverse norm by pressing second bars. Inverse norm is number 3, and the area is the area on the left, the one I have to provide here. If you have 0.025 area on the right, you gotta take away from 1 minus 0.025, and then we keep that as 0 and 1 as the mean and the standard deviation, and then we paste that here. So this is the critical value, 1.960. Let's round it off to the third decimal place. And once we have that critical value, all we have to do is type all this formula. I mean, the margin of error is 1.960 times the square root of p hat. This is p hat, the one we obtained from the sample, uh, 0 no 0.525. Okay, and q hat is the complement of p hat, so that's 1 minus p hat. Okay, so this value we obtain it by doing 1 minus 0.525, which is 0.475. All this divided by the sample size, which is n. N is a 1060. Okay, so let's type on the calculator. What I'll do is type from the inside out. So let me type 0.525 times 0.475. Divide all these by the sample size, which is 1060. Okay, I press enter and I get this number. So I need to take the square root of that number. So I press second x squared here, that's where the square root is located, and this number I press second and minus, which is that answer that I got here, and I press enter and I multiply this by 1.960. so multiply this times 1.960 and I get this value, which is the margin of error, the one I have here. Okay, so the next part, it says construct the confidence interval. Well, the confidence interval, the formula for that is this. Okay, it's p hat minus the margin of error, that's the lower limit, and the upper limit will be the p hat plus the margin of error. So let's take these values from these previous steps, and we do let me clear the home screen. I'll do p hat, which is 0.525 minus the margin of error, which is 0.030, and that is that lower limit, and 0.525, which is p hat plus 0.030, that is the upper limit, that is right here. Okay, so that's how you compute this on the calculator. Okay.